All right, here we are at P12b. Our goal for P12b is to write a polynomial function in standard form given the zeros. So if we start with the zeros, how do I go all the way back to writing the polynomial function in standard form? So here I'm going to go ahead and write the steps, and then we're going to do a couple of problems. And I really want these steps, as we write these steps, I wonder if, does that show up? Weird. All right, so as we write these steps,
Could we have a custodian to open 116B? A custodian to please open 116B. Thank you.
as we write these steps, I want you to think back to finding the zeros from factored form, right? We set each factor equal to 0, and then we solve. Well, we're going to be going backwards, right? So the first step, and this is really strange. So the first step, I don't know if, here in a little bit, I'm going to find out if the, can you see the zoom in and zoom out? The zoom in and zoom out. I hope it doesn't show up on the video, but if it does, I'm really sorry about P12a. All right, so P12b, here we go. The steps to writing a polynomial function in standard form when we start with the zeros. So the first step we're going to take a look at, step 1, all right, that's about right. Okay, step 1 is going to say, we're going to make the factors. We're going to make factors from the zeros. And step 2, we're gonna put those factors into factored form. Put into factored form. Step 3. This is the hardest step. Easy to write, not hard to do, but of the bunch, this one's the tough one. Here, then we're going to multiply, and that's it. That's as far as we're gonna have to take it. All right, so let's do a couple of example problems, and then we're going to see how this works out. So our example problems. All right, so the directions are going to say write a polynomial function of least degree. It's going to have these little weird things. Don't worry, the process is the exact same. It's going to say some weird stuff, but the process is the same thing. Given the following zeros. All right, so this is what the directions are going to say on our work. So, our first example. So they give us the zeros. They're going to say something like -2, 1, and 5. Okay? All right, so there's 3 zeros, which means that the degree of this polynomial will end up being 3. So the way I like to do this, so we're going to make factors out of the zeros. And here's how we're going to do this. I'm going to start off and I'm going to say x equals -2, x equals 1, and x equals 5. And if you notice, I'm going to show you notes from our last one here. That's where we ended, right? We ended at x equals -2, 4, and -1, right? So now, think about how can I go from here backwards. So from here to here to here. All right, so here we go. I want to get 0 on the other side. So here I'm going to add 2. So x plus 2 equals 0. That would be my first factor. I'm going to subtract 1. So x minus 1 equals 0. That would be my next factor. If I subtract 5 from both sides, I get x minus 5 equals 0. And that would be my third factor. Step 2, I need to put it into factored form. So f of x equals, these are my factors. So I'm going to say x plus 2, x minus 1, and x minus 5. And now, part 3, I need to multiply. And just for a second, I just want you to recall something here. If I had to multiply 7 times 5 times 2, right? 7 times 5 times 2. I'm multiplying three things, right? Just here, like here, I'm going to multiply three things. Here, I can multiply these three things. If I wanted to, I could do 7 times 5 is 35, and 35 times 2 is 70, right? I could have also, with 7 times 5 times 2, I could have said 5 times 2 is 10, so 7 times 10 equals 70, right? So the order doesn't necessarily really matter as to how I multiply these. What order do I multiply them in? I just need to remember that when I multiply two of them, I still have to multiply the third one. What I see a lot of people do when they do this is they'll multiply x minus 1 and x minus 5 and totally forget to multiply the x plus 2. Now, I like to do these on the right side first. This is just my personal preference. You can do it however you want. However you want to multiply these out, it's completely up to you as long as you multiply them thoroughly and combine your like terms appropriately. So here we go. I'm going to multiply x minus 1 and x minus 5 first. So I start off and I write x plus 2. Then I put these brackets. And I'm going to do all the multiplication because I know that there's going to be a step of simplification before I get to the next one. So x times x is x squared. X times negative 5 is negative 5x. And then negative 1. Negative 1 times x is negative x. Negative 1 times negative 5 is a positive 5. And then I need to combine my like terms in the middle. Negative 5x, negative x is a negative 6x. So here I have x plus 2 times x squared minus 6x plus 5. Now, I need to multiply x plus 2 times, or this binomial times this trinomial, right? So, distributing x first. X times x squared is x to the third. X times negative 6x is a negative 6x squared, and x times 5 is a positive 5x. Distribute the 2. 2 times x squared is a positive 2x squared. 2 times negative 6x is negative 12x. 2 times 5 is a positive 10. And now we can combine our like terms. And I like to combine my like terms with my function so that it's all set up in the end. There's only one x to the third, so here we go, x to the third. Negative 6x squared and plus 2x squared is negative 4x squared. 5x and negative 12x is a negative 7x, and 10 all along. This is the function in standard form given these three zeros. All right, so remember, the zeros, set them up, get them into factors, put your factors together, multiply. Remember that you have to combine like terms a couple of times, and you're going to be in really, really good shape. This is not very difficult. It's just an exercise in multiplying, and you have to multiply a couple of times. I'm going to do one more example. I'm going to do one more really quick example. What happens whenever we have fractions and zeros, all sorts of stuff. So we're going to do one more example. So the directions are the same. I'm going to give you a couple. They're going to give us some zeros, and we need to put it into factored form, multiply it out to get it to standard form. All right. So this is our second example. The zeros that they give us, we're going to have 0, 2/3, negative 4, and negative 1. All right, so the zeros that we were given, 0, 2/3, negative 4, and negative 1. All right, just as we did before, I'm going to say x equals each one of these. So x equals 0, x equals 2/3, x equals negative 4, and x equals negative 1. Now, the goal here is to get 0 on the right-hand side. So here, I'm done. I don't have to do anything with him. With this one here, if I multiply both sides by the denominator first, I'll get 3x equals 2.
Any teachers on plan today, please give me a call at 7114 if you're willing to cover a class. Again, any teachers on plan today who are willing to cover a class, please call me at 7114.
I'm not going to cover today because I got Oklahoma Joe's for lunch, and I'm going to eat it during my plan period. Meh. Yeah, I have ribs from Oklahoma Joe's. All right, so remember, whenever you have a fraction here, multiply by the denominator, and then you're going to move the number over. So we'd end up with 3x minus 2 equals 0 for this guy. On here, we're going to have to add 4 to both sides, so I get x plus 4 equals 0. And here I'd add 1 to both sides, and I get x plus 1 equals 0. So now I have all 4 of my factors. And then I could set it up in factored form. F of x equals. Now remember, with that x equals 0, again, this is the weird guy. He's just x. And then we have our 3x minus 2. And then we have x plus 4. And then we have x plus 1. All right, so now going through and multiplying these out. I'm going to start with these two, and then I'm going to multiply this one, and then finally on the last part I'm going to multiply the x. So x plus 4 times x plus 1, so I got to get these in first, right? So that's a 3x minus 2. And I want to use brackets because I have to simplify. All right, x times x is x squared. X times 1 is x. 4 times x is a positive 4x, and 4 times 1 is a positive 4. Now I got to combine my like terms, right? Give it a little CLT. X times 3x minus 2. And now I have x squared. X plus 4x is a positive 5x plus 4. Now I'm going to multiply 3x minus 2 with this trinomial. So the x goes here, and my brackets, because I have to do a little bit of simplification. So 3x times x squared is 3x to the third. 3x times 5x is a positive 15x squared, and 3x times 4 is a positive 12x. Now we got to send the negative 2 over. Negative 2 times x squared is negative 2x squared. Negative 2 times 5x is negative 10x. Negative 2 times 4 is negative 8. Now I got to combine my like terms. There's only one x to the third. And then I have 15x squared and a negative 2x squared to give me 13x squareds. Positive 12x and negative 10x gives me a positive 2x and a negative 8. And lastly, my last bit of multiplication is this x. I'm going to distribute him through. So I get f of x equals x times 3x to the third is 3x to the fourth. X times 13x squared is a positive 13x to the third. X times 2x is a positive 2x squared. X times negative 8 is a negative 8x. And I am done.